Hello and welcome to the SEAI's 180 Degrees podcast. I'm your host, Sinead Ryan, and over the course of the next 12 episodes, I'll be joined by special guests to talk about the state of play of Ireland's energy revolution, how we can be smarter energy users, what renewable technologies are coming into our homes and communities, and how small businesses can benefit from decarbonising now. Hello and welcome to episode 2 of the 180 Degrees podcast. I'm Sinead Ryan and you're very welcome along to this episode. Now look, we've all heard about them. We've all heard about how expensive they are. So is a heat pump really worth the investment, and how easy is it to install and maintain? Well, I'm delighted to be joined again by Brian McIntyre of the SEAI back for this episode. Brian, you're very welcome along back to studio.
Thanks,
and later on in the pod, I'm going to be joined by a homeowner who's going to share her experience with installing, fitting and living with a heat pump, and we'll hear from Pamela later on. Now, let's start out, Brian, by explaining a little bit of the techie side, the science bit. What is a heat pump? How does it work?
It's basically just a source of heat. It operates similar to how a fridge works, where a fridge extracts energy from inside the fridge to keep it cold and dumps it out the back. So if you felt behind the back of a fridge, you'll often feel it quite warm. So a heat pump is the same in principle. It's extracting energy primarily from the air in Ireland in terms of air source heat pumps and using that to generate heat, to heat your hot water, say to run through your radiators or to underfloor heating. So that's basically how it works. You're just extracting energy from the air or from the ground or from water to, without getting too sciencey, you compress it, make it hotter.
Put it in the magic box and
exactly,
convert it into heat in your home.
It takes heat in, goes into black box, bish bash bosh, and you get heat inside the house.
Fantastic. Okay, all the engineers out there are crying into their cup of tea at the moment. So Brian, I know there are different types.
Yeah.
Ground to water and air to water. That confuses me. What are they, and does it matter which one you get?
It doesn't matter in the sense that the technology works. An air source heat pump is the typical one we'd have in Ireland, where you're extracting the air. An air to water one would be most common, where you're extracting energy from the air and use the heat water to put around your radiators or your underfloor heating.
Okay.
There's also an air to air, which would be more common, say in Scandinavia, where they have a lot of heat pumps, and it's basically it's like air conditioning. You're heating air to blow through units around the house to kind of warm the air that way.
And maybe commercial premises as well, that would work. Okay.
Ground source then would be where you either have a pump going straight down into the ground and you're putting a refrigerant down through it, and that's extracting energy from the ground and bring it back up. Or if you've got a lot of space down the country, a lot of people might have more space and they just have a shallow trench, say, going around the gardens place, and it's about a metre deep, and the pipework goes down there. So it's ultimately extracting heat from the ground. It would be slightly more efficient than an air source heat pump because the ground is stable all year round. So it's the same temperature extracting from. It's a bit more expensive because you've a lot of the pipework going outside in the garden when you're going down or across at a shallow level. There are some in Ireland. They're not as common as the air source heat pumps, but they tend to be where people have more space.
So air to water. So that makes a lot of sense. You're taking it from the air and to convert it into water, which goes around the rads and keeps your radiators warm. So that would probably be the one that would suit maybe urban homes and the more obvious ones.
Yeah.
Good. Okay. Now, I presume you don't have to know all that if you're a homeowner, because you can get expert advice maybe to tell you what you should have.
Yeah, an installer will come around and say, look, you're probably going to need an air source heat pump in the area. You don't have the space to ground source. It could be, and even if you do have the space, it'll cost X amount more. So you have to weigh it up. You might have a decision to make and say, look, I could go ground source or air source, but this is going to cost.
And do they all cost around the same price then? Is it just a technical question?
Well, it would be more expensive for the ground source because
of the
pipe
digging.
work. Yeah, if you go straight down or if you dig up the garden. It's just more the capital cost at the start. The running cost would be a bit lower because, like I said, you have a stable temperature. So you're getting the same amount of heat all year round, whereas it can up and down a little bit. With
swings and roundabouts.
Exactly.
Right.
Yeah.
Okay. Now, how long can a homeowner expect to get out of a heat pump? How long will it last?
The service life should be 20 to 25 years for a heat pump. I think there's a perception that they don't last. Maybe it's a case that they were put in maybe 15, 20 years ago into older houses, or not put in poorly, or you had people that didn't really know, or there's very few people that knew how to install them and they were put in badly. And then the engine, essentially, the heat pump, is working overtime, and it just shortens the lifespan of it. But if we're to put in now, especially in the grand schemes where you have a certain amount of they're working efficiently, it's much less taxing on the engine of the heat pump itself, and they last a lot longer.
So I think people might be wondering, look, we'll get onto the cost and the grants in a while, but people might be wondering, if I'm going to have a 20, 25 years, what's the turning year for the payback, for my investment? What's the point at which the savings that I'm making on my bill is actually repaying maybe the loan I had to take out or the costs that I had to put into the original one?
Yeah, it's a tricky one because the efficiency can change over time, and some people might have it up at 22 or 23 degrees for whatever reason. Maybe it's, and we've seen that, say older people in a house, their comfort level might be 23 degrees. So that'll reduce the efficiency of it over time. So your savings, your payback is a little bit longer. And I think as well, a lot of people put them in, and Pamela will probably talk about it as well, is about the comfort side of things. That we've, for years, and it's whether we're talking about heat pumps or talking about upgrading our insulation, that we always look at it purely through a costs versus payback prism. And we always say, like, you're judging it purely on the cost and payback when you're doing something to your house. Like, if you put in a kitchen, no one puts in the kitchen or buys a new Swedish furniture and says, like, how long is it before it pays for itself?
Well, no, I'll press you there, Brian, because they might. I mean, lots of people do that. They say, certainly I know people who buy clothes and they calculate it on a cost per wear, maybe to justify getting something super expensive. But look, it is an important consideration. And for people maybe who aren't primarily doing this to save the planet, which we hope they are, but it is a big investment.
Yeah.
It is an expensive piece of kit. You've people in and out of your house, and people want to know, no more than the solar panels, which we'll be tapping on in a later episode, when is the point at which my money, makes this worthwhile? I mean, is it year 5? Is it year 10? Because if it's year 20, people might be put off by that.
Yeah, no, that's a fair point. I'm not trying to disregard the cost side of things as well. I mean, it's a massive consideration. And that's when you come into, if you're looking at a long-term investment in it, that's when the other things like the comfort and it's the constant comfort level inside the house that add value onto the payback over time.
Yeah, and of course a lot of the time, maybe it might be the case people aren't just getting a heat pump fitted, they're getting other things done as well, and it's kind of a holistic approach, isn't it, to the investment?
It is one of those things, like, people will always, like, you're not going to spend that level of money on just to do it for the planet or to do it for the environment. There has to be something in it for them. And surely there is the savings as the cost of electricity drops back to kind of a normal level. It's spiked up over the last 2 years. It's dropping back now. We'll see some reductions in electricity prices in the next couple of weeks. And as that comes back to a normal level, you will see more savings versus, say, a gas or an oil boiler.
Okay, now
so that will reduce the payback as
well. Talk to us then about the happy stuff. Give us some of the benefits. If every house in Ireland got heat pump fitted, or all the ones that could, how would that help us with our carbon targets, or what would that do for us from an environmental viewpoint?
Well, the first thing is, like, because they're so much more efficient, like a heat pump will typically be about 3 times more efficient to a gas boiler. So you're using a lot less. So it'll use a third of the energy. We're moving away from gas and fossil fuels, so we're a lot less dependent or sensitive to issues happening around the world that can cause a spike in prices, but also reduces the emissions. Because we're not burning as much fossil fuels and reducing solid fuel usage, air quality becomes a lot better. So by electrifying heat, as we move more and more towards a lot more renewables, as towards 70 or 80% of our electricity is generated from renewables, we've much more cleaner electricity sources, and electricity is going to power our heat pumps. So again, it's just about reducing our carbon emissions and cleaner air quality.
And then in terms of the household, for a house that gets a heat pump, what are the immediate effects that homeowner is going to notice?
It's the constant temperature thing. I think the comfort thing we've always found, people always do it to get the savings, but they find the biggest benefit is the comfort. There's a misconception that they're always on 24/7, keeping the house at 21 degrees, for example. It's set at those times to come on at the times you want it to be at 21 degrees, and then you drop it back to, there's a setback temperature. So it'll just...
Yeah, because that might be a bit high if you're at night time when you want to sleep. That might be a little high temperature.
Yeah, exactly. So you can set it up to setbacks. It runs to keep it at 21 degrees when you want it at 21 degrees, and it'll switch off then again. So it's like a heat pump is similar to an airplane. When it takes off, it uses a lot of its energy. And then when it's cruising, it's using very little energy. And the heat pump is the same. Like, a lot of its energy is used in bringing it back up to temperature. And that's why we don't see heat pumps turned on and off like you would with a gas boiler. So you'd bring it up to a temperature, and then you keep it, and you just bring it up to the temperature 21 degrees, and then maybe you drop it back to 17 or 18
So no
degrees.
more than keep, like, the analogy would be keeping your heating as you know it now on the whole time and letting the thermostat knock it on and off when you're going. Okay. So benefits to the home, benefits to the planet if we get them. Now, we were talking about the costs there. Talk to me now about the good news on that in terms of the grants that the SEAI offer towards that. So I'm going to ask you to be specific, right? You're going to give me an example, say, for a 4-bed house, a regular home that people are living in right now. What will it cost them to get it in, and how much are you going to give them out of your pocket or the SEAI's pocket?
Yeah, again, to a degree, this is an it depends question. But typically, if you have a relatively new house, say maybe 25, 30 years old, there's a good chance you might not need to replace the radiators, especially like people might have upgraded their boilers over time and got a new, more efficient boiler, and the radiators will have increased in size. So they might actually be suitable to run a heat pump through. You might not have to replace the pipework. So you could be looking at maybe 10 or 11,000 euros to get it done. And the grant for that would be 6,500 euros.
So that's very generous when you think about it. That's half the price.
Yep. And that's through the individual energy upgrades. If you're doing a big package of work through the one-stop shop like Andrea would have discussed in the last episode, where you're bringing a house up from an E, F or G up to a B or even an A, the government wants to incentivise people to do that. So on top of your 6,500 euros grant for that, you get another 2,000 to cater for the radiators and the pipework that might need to be upgraded.
Oh, okay.
And then a bonus of 2,000 euros for achieving your
just for
B
doing
rating. To achieve the rating, yeah, exactly, with a heat pump.
Okay.
So you could get up to 10,500 through that one-stop shop program where you're doing all the big package of work in one go. But it's 6,500 if you're just doing individual grants.
Okay, Brian, but in terms of the cost, I mean, people are going to get varying quotes and they'll need varying works. And we know that a heat pump isn't suitable for every home, or as you said, it's only suitable when you get other works done. So might it be the case then that some homeowners might find that while the heat pump costs X thousand euros, in fact, they have qualifying works that might jack up the price a bit?
Yeah. Absolutely. I mean, if it's an older house that they might need to replace the pipework, they might need to replace the radiators, or maybe they've decided to go underfloor heating. So it's that would make it more expensive. Like you're looking maybe at 17,000, 18,000 euros to get that done, if that's all in price. Again, depending on the size of the house and how many radiators you need to get done.
Yeah.
But it's really worth shopping around to get different quotes and making sure you understand what's included in that quote. Because sometimes people might put in, it looks like a higher cost, but the actual works they've included within that, it might be underfloor heating that they've provided for instead of radiators.
So that might be just an added opportunity to say, look, while I'm getting this in, there's a whole other piece here that, because they work well together, the underfloor heating and the heat pump, don't they?
Yeah, absolutely. It's one question we do get a lot of is like, do you have to have underfloor heating for them to work efficiently? And it's not really the case. We see the vast majority of heat pumps are installed at houses with radiators and they work really efficiently. It will be even more efficient on top of that underfloor heating, but they'll absolutely operate efficiently with radiators. Okay,
so usual consumer advice applies. Yeah. Shop around, get several quotes, don't take the first one, and get an idea of what it is that you're comparing like with like. Isn't that it?
Exactly. Okay. I understand the quote and what's included in it.
Now, in order to get the grant, tell us what people need to do, because you don't want to go out shopping for a heat pump before you know all this stuff.
Yeah. So the first thing for a grant, you'd need to carry out a technical assessment, and that's basically to assess the level of heat loss from your home. Because if you're losing a lot of heat, it means the heat pump has to work harder, like any heating system would do. It's like if you take your house like a bucket of water. So if there's lots of holes in the bucket, the water is going to flow out. So you have to add more and more water. And it's the same thing with your house. If you've got a lot of holes in that bucket, you're going to lose heat out left, right and centre, and it means the heat pump has to work harder and harder, so you're using more and more electricity. Its efficiency reduces, so it's more expensive. So we have a technical assessment to see if the level of heat loss is at a certain level that it makes sense to put in a heat pump. So they'll tell you, it's like, is it heat pump ready? And then you go ahead for the grant. Or they'll say, look, you probably need to upgrade your attic insulation, for example, or maybe if it's a really old house, you might be looking at wall insulation. So you could be looking at maybe it's just insulate your attic.
To do first, to get it ready. Yeah. But there's grants available for that as well. So you can get kind of the whole picture in one go before you make your decision. Yeah. Okay. Now, what is involved in fitting one? I mean, do you have to up sticks and move into a hotel, or how long does it take? Just straightforward for the hot water cylinder and for the heat pump itself, it's probably a day, 2 days of disruption. And again,
the disruption's really around you don't have heating. So I'd ideally try and get it done during the summer. Yeah, exactly. But people don't think about teeing up these things till it starts to get cold again anyway. So it's just human nature. But
no, you're not thinking about the heating.
Yeah, exactly.
I need to do it differently this winter. So you're saying July is the time to be doing that.
Just if you need these things, start looking at them earlier on in the year and plan them for during the summer. So a day or two, if that's the level of work, it's just the heat pump and hot water cylinder. If it's radiator and pipework, it might be another 2 days on top of that.
Okay.
You don't necessarily have to leave the house to be working away around it, but it just, again, you have a longer period of time without the heat.
Any of the heat pumps I've seen are usually sitting in the garden or on a patio, and it looks as if it's about the size of a dishwasher or a little bit smaller than that maybe. So I'm concerned about maybe smaller homes or apartments that just simply wouldn't have that space that they want to give up.
Yeah.
To have a heat pump fitted. What would you advise them?
We see more in apartment blocks, especially if there's one, say, a developer or one body over it, that they might put in like an exhaust air heat pump, or you just have the units going into it. So not every unit has to have it. And down the line, we'd be looking at things like district heating. But it is an issue. If you don't have space, it's not going to suit everyone. I think it's no point to me saying that it is going to be.
Because they are fairly hefty in terms of the size that they need to be.
Yeah. I mean, if you have a boiler outside, there's a good chance you could accommodate the heat pump outdoor unit itself. Again, there might be a space issue where you put your hot water cylinder, but that's not insurmountable. I think there's a lot of people, there's ways and means around these things. And
I wonder then with technology, as we move on in the years and decades, it'll probably, a bit like computer chips, it'll probably get smaller and more efficient as time goes on.
Exactly, yeah. I've seen in England, there's a company called Octopus Energy, and they've tried to make them more attractive, because there's a thing like, there's a lot of stories
like
going on, they're ugly.
Heat pump, is it the Barbie themed?
Yeah, it's kind of like that. Yeah, it's more colourful, and I think people say they're ugly. I mean,
Listen,
I don't think boilers
it worked for the Apple Mac. No reason that it won't work for a heat pump.
Boilers aren't particularly attractive, so I don't know where needs to stick to BT pumps with to say they're ugly. But yeah, I think they'll become smaller, take up less space. I think the technology will evolve. It already has. And
tell me about the noise factor, because now if it's out in the garden, you probably don't care. But you know, if you're out there having a barbecue or on the 3 days of the year that we're able to do that, is there a noise associated with it? Will the neighbours start giving out?
They're usually not positioned near the neighbours anyway. I mean, I hear the boiler comes on at home, and the level of noise from a heat pump would be roughly the same as you get from a boiler, and the noise is coming down. It's not really an issue. I think more of it is made than there needs to be.
So it's like a hum in the background.
Yeah, no more than an ordinary gas or oil boiler would do. So it's to me, it's a non-issue. I haven't heard anything that's excessive from them.
It's not a big motor.
Yeah, it might be an issue. They usually come with like anti-vibration platforms that they put them on, so you don't get that reduces the noise as well.
And tell me, Brian, about the maintenance. What's involved? How often do you have to get somebody in to check it out?
Like with every boiler, it's every year, ideally. I think the maintenance tends to be less because, like with a gas or oil boiler, you have the ignition inside, so there'd be a build-up of soot that they have to clean out. And it's much more straightforward. But again, it's just to make sure it's operating efficiently, ideally every year. Okay,
all right. And then what happens? Because we've been warned, really, you know, with all the excess energy we're using, and particularly the massive data centres that are in, that we could have periods during the year where you have a blackout, or, you know, the electricity goes off or a wire comes down. Does that get affected? Does the heat pump go out if that happens?
The heat pump, yeah, if you don't have electricity, you can't operate the heat pump.
Okay, but so that's its power source.
Yeah, but if you don't have electricity, you can't run a gas or oil boiler. Yeah. So because they need the electricity to run to the ignition or circulate the hot water around the house. So it's, yeah, a heat pump won't work, but a gas or oil boiler won't work either.
Now, in terms of, we spoke in the last episode about the bills that come in from our energy supplier, and the kind of some of the plans that you can have, and how confusing everything seems. Does having a heat pump, does that change maybe the type of metering or the type of bill you'd be on, or the supplier, or does it not matter?
It would make sense. I mean, that's one thing we'd be looking to down the line. You'd be seeing with everyone getting smart meters, and they'd have heat pump tariffs that operate, because we want to incentivise people to move towards heat pumps and electrified heating, so it makes sense to have a tariff that would reduce the cost for people. But you'd be offered opportunities to make aware of a better tariff that would work for a heat pump, but it won't necessarily change. But the smart meter will allow energy suppliers to offer preferential tariffs to reduce the cost of electricity for people.
Okay, good. All right. Now, we're going to take a break just for a minute, Brian. Don't go anywhere. I'll be coming back to you, because I'd like to talk now with a homeowner who has been using a heat pump for some time and get her experience on it. And that is Pamela Potterton. Pamela, you are very welcome along to the 180 Degrees podcast, and thank you for joining the conversation.
Thanks, Sinead. Thanks for having me.
Now, tell us why you decided to get a heat pump?
I guess when we were building the house, it's probably 15, 16 years ago, our main driver was to avoid any reliance on oil. I suppose we wanted to be conscious of the environment, but also of our pockets going forward as well. And whilst we were building the house, we had an opportunity to really sort of step back and think about what type of heating system we wanted and needed.
And in doing that then, how much research did you do into it? Did you look at different types or different styles? And of course, your budget?
Absolutely. We're certainly far from experts on it. So we very much relied on a lot of different sources. We spoke to, like myself, a homeowner who had actually installed heat pumps. We had looked at, the solar panels. We had experts come out on site and look at what was most appropriate for our house, the location, the size of the house. And you're absolutely right, budget has to be a consideration as well. So we did have, as I say, experts come out on site, and they recommended a ground to water heat pump. And we have the horizontal pipes laid out in our garden. So that was installed along with underfloor heating, both upstairs and downstairs. So all the research, all the experts seem to concur that that was probably the best solution for us. So ultimately we went with their advice.
So you got the whole shebang, as it were, when you were getting it done. Now, we've been talking a little bit in this episode about the physicality of it, the size, the structure, the noise. Tell us your experience of how that has been.
It's funny, we had a lot of people kind of say, there's a noise off it, or, it can take up a lot of space. For us, that wasn't our experience. We went for a larger heat pump, which has an integrated tank for the hot water, so that it is quite sizable. It's about the size of sort of a single door sort of standard fridge. But we chose to put that into our utility room. It itself generates a lot of heat, so actually it's great for drying. And I mean, mud rooms now are all the rage, so we sort of had one before it was even a thing, before we even planned one. So it very much is a lovely warm space when you come in from being outside. In terms of noise, there's very little noise. It's certainly no louder. We would find it's certainly no louder than a normal sort of fridge or anything like that. And we then upstairs, there's just a manifold for the underfloor heating, which is connected to the unit downstairs. So we thought it was relatively small space compared to some of the stories that we had heard.
So that's reassuring for other people who may be thinking of it now and wondering, are they going to hear this constant hum? Although I suppose, like most things in a house, you kind of, your brain ceases to hear it after a while, and maybe it's only at the beginning. Now, what was involved, Pamela, in the fitting of it? Did you have to move out of the house? Was it a huge job, and how long did it take?
I suppose we were fortunate enough that we were building the house from scratch when it was being installed, so we didn't have sort of the hassle of having to move out. The only maintenance really involved in it is having it serviced probably once every. You're probably supposed to get it done every year. We're probably every 2 years, to be honest. But there certainly hasn't been any issues or any concerns that we've had to consider in whatever it is, the 15, 16 years that we have it.
And what are the immediate benefits that you noticed from having it? Have you lived in houses that have had traditional boilers and heaters? Tell me the difference.
Absolutely. And I think that was probably why we were quite driven to look at alternative solutions. I suppose the cost is the big element, and the environmental side of things. So absolutely, that was a consideration. But in terms of the heat, the one thing that people say when they walk into our house is that, oh gosh, it's lovely and warm. And we don't have to worry about adjusting temperature controls. There are some, and you can turn up and down the temperature in different rooms if you want. We generally don't. We've kids, so doors are open anyway, so it's irrelevant whether there's rooms that aren't being used as much or spaces that have more traffic than others. But certainly there's a nice constant heat throughout the house at all times. Generally in the summertime, we turn the heat down to relatively low, so probably 17, 18 degrees. And then in winter, we would put it up to probably, 21 maybe degrees. And the temperature then would remain that constant throughout the house. Probably then on the flip side, the one sort of con, I suppose, that would come with it is that if you've been outside for a couple of hours and, you know, it's winter or any time of year in Ireland and it's particularly cold, there's not always sort of an instant blast of heat maybe to dry you or your clothes or whatever it might be, but the temperature is quite stable and it's quite nice.
Okay. And is there anything now for somebody who's thinking of it, undertaking that project at the moment, anything you would have done differently or that you advise them to do?
I'm sure the systems have improved even in the time since we certainly got ours installed. I think it's absolutely crucial though to speak with somebody reputable and somebody experienced in installing these, because there are different types. I mean, even how the pipework is laid in the garden and things like that. So I think it absolutely get the experts in terms of doing things differently. To be fair, I think we'd probably actually have maximized where the unit is stored, because we have, I suppose, an opportunity there with the sort of the heat that it generates to just sort of, you know, even dry clothes and things like that, and probably actually make use of all that and really maximize that, because it certainly is. It certainly has been a positive experience for us, and we didn't anticipate just how, I suppose, efficient it would be and just how ambient the house would remain throughout the year.
Lovely. I'm jealous now with the cold weather out there. Pamela Potterton, thank you so much for joining us and giving us your real life experience of heat pumps on the 180 Degrees podcast. Okay, Brian. So that was Pamela's experience, and actually I learned something from that, because we were talking about putting heat pumps in the garden and on the patio. She has it in a utility room, and it sounds like she's getting a double use out of it there. She's getting a drying space as well. Do you find most people, if they have the space, that would be actually better?
Yeah, I mean, I suppose it's one of these things. It's whatever suits your house. I mean, that suited work best for them. I don't know if I was looking at getting it done, the hot press would be the obvious place for it because it has the room for it. But yeah, like one of the things that an installer will look at is where does it suit you to put it.
Okay, so that's one of the things you can consider though. Yeah. It doesn't always have to be, you know, taking up space in your garden.
Exactly, yeah.
Okay. Now, where can people find out a little bit more, get their assessments done and find out all about the financial side?
Again, it's on the SEI website. So if you go to the grant section, it kind of walks you through the application. So the home energy grants and the individual energy upgrades. And when you click into heat pumps, it basically takes you through a step-by-step process. So about getting your technical assessment first. When you've done that and your heat pump ready, you can go to a registered contractor who's registered, and to be on that registered, they have to be trained up in sizing and designing the heat pump and installing them and all that sort of thing. So if you go to the website, sei.ie, it'll have all the information.
There's
there.
Experts to do all the heavy lifting for you there.
Yeah.
Right, okay. And so if I decide to go ahead and I get the heat pump and my grants in place and all of that, then people will come in to fit it. Is my old boiler taken away? Does it remain in place, or what happens?
No, they'll usually take that away.
Brilliant. Okay. Added bonus. Right. Freeing up a cupboard
exactly.
to use for something else. All right. Listen, Brian McIntyre of the SEI, that is a great deep dive into heat pumps and all that they involve and everything about them. Thank you for joining me today on that. And that's seai.ie for anybody who wants to find out more. Tune in next week for a mini episode where I'm going to hang on to Brian and take 5 minutes with him to go through some of the questions that come in to the SEI frequently on this very topic, and I'm sure yours may well be among them. So do tune in for that. And until the next time, it's goodbye from me and the 180 Degrees podcast. If you've enjoyed this episode of the 180 Degrees podcast, well then why not review and subscribe to it now? And of course share it with family and friends to find out more about renewables and energy. Well then check out seai.ie.